Good afternoon. My name is Dinesh Mishra, and I work as a database admin on DB2 on mainframe systems. Currently, I'm pursuing my master's degree in software development and cybersecurity from Technological University of Shannon, Athlone. The purpose of this video is to showcase the Java client-server application that I have been developing to understand the basics of communication between client and server using AES encryption and Diffie-Hellman exchange. So first of all, there are three classes that I have defined under the Java packet assignment one. Okay, so the three classes under the package assignment one, uh, I have defined three classes as my client, my server, and my user. My client is the class which is defined for the client server, which is establishing a connection to server using the port 2000. Because I'm using the same machine for server and client, I'm using the local host on this one. In the client, it generates the Diffie-Hellman parameters using the prime of p, base as g, and the key size of l, and it then send over the Diffie-Hellman parameters to the server. It also generates the client key pair, which is then exchanged with the server, and then the public key is exchanged between both this client and server, and then the secret key will be shared. In the client, there is an object for the my user is being created, and my user is a separate class which is defined here to which does the serialization. So in the client it will be serialized, and in the server it will be deserialized again. So in the server class, if you look at this, it is also using the same server socket on the port 2000, and it accepts uh, it accepts the client socket using the object input streams. So when the connection is established, first of all, it will wait for the client to be connection when the server application is running. And once it is accepting the client request from the port 2000, it will show the message as client connected. Then it will accept the Diffie-Hellman parameters shared by the client, and it will generate the keys which will be then exchanged with the client. And once this secure connection establishes, the data, the user data, which has been created as a user object, will be exchanged. But there is the encryption and decryption. So first of all, the user data will be encrypted in the client. For that, an encryption AES encryption method encrypt message has been created. So using that, it will convert the my user object into the byte array, and then it will be sent to server where it will be received. So let's go and run this. Okay, let's now run this program. So I'm starting the server program initially. So server is waiting for connection. Then if I go and run the my client, it will send a request to server and then establish the secure connection to send over the data, user data. So the client is connected. The client has generated the Diffie-Hellman parameters and encrypted them using the AES key. And it has shared the AES key, which has been created successfully. And the encrypted object has been received by the server. In the server, then it decrypted the encrypted object received using this decrypt message, and the cipher is the same, and the encryption key encryption thing AES is used to decrypt the received encrypted object, and the decrypted result is. Let's now move to the next part of the video, that is the difference between the TLS 1.2 and 1.3. So I have created a short presentation to explain the key differences in the TLS 1.2 and 1.3. So, first of all, transport layer security is a foundational technology for online privacy. As a cryptographic protocol, transport layer security encrypts the data and authenticates the connection when moving data over the internet via HTTPS. So, whenever a user visits any website, the browser checks for the TLS certificate on the site. If there is a certificate existing, then the browser performs the TLS handshake to check the validity and authenticate the server. Once the link has been established between the two servers, TLS encryption and the SSL decryption enables the secure data transport. I have explained the TLS handshake for the two technologies like TLS 1.2 and 1.3 in this one. So the basic difference is like the handshake speed in 1.3 has been significantly higher than the 1.2. And why is that? Is because the TLS 1.2 requires two round trips to establish the connection between the server and the client, whereas TLS 1.3 reduces this because it only needs one round trip. So that's the reason. And sometimes for the repeat visitors, it doesn't even need to re-verify or the certificate. So it's the zero round trip. The next difference between the two technologies is the key exchange. The TLS 1.2 supports the multiple key exchange method, including the vulnerable ones like static RSA and the non-ephemeral Diffie-Hellman, whereas TLS 1.3 mandates the ephemeral elliptical curve Diffie-Hellman. So that ensures the secrecy by default. The next feature, which is different in two technologies, is encryption and integrity. So TLS 1.2 allows older algorithms like cipher block chaining and even the broken ones like RC4, whereas TLS 1.3 only permits the modern authentication encryption with associated data, AE, and it combines the encryption and integrity checks efficiently while eliminating the padding oracle. TLS 1.3 is highly secure because it has removed a lot of insecurities that are present in TLS 1.3, such as it has removed the SHA-1 hashes and it only uses the SHA-256 or 384. There is no compression in TLS 1.3, which prevents the crime attacks or the downgrade attacks because it doesn't use the negotiation. It has also removed the insecure cipher suits like RC4s or 3DES or CBC in TLS 1.2. Thereby, 1.3 has simplified the design using these fewer cipher suits and it removes the legacy features, reducing the configuration errors. In conclusion, the TLS 1.3 offers the better security, faster performance, and simpler deployment. It addresses the decades of cryptographic research and real world attacks, making it a clear choice for the modern applications. Thank you.